Let's go into the next speaker. Our next speaker for today's event is Donia. And Donia is a Donia is a backend engineer at Powder. She develops social gaming apps, and she has 5 years experience working with Go. She found at the intersection of people and tech community. So she just opened a new chapter. Okay, Donia opened a new chapter at Sophia Antipolis, GDG, Sophia Antipolis. She strives for diversity and she's actively engaged with organizations promoting women in tech. Actually, I met Donia through a colleague at HelloFresh, and since we've met, it's been an amazing journey. She's so active and super energetic, and I'm really excited that we'll be learning a lot from her today. Please join me to welcome Donia to the virtual podium.
Hi, everyone. Can you hear me well?
Yes, we can hear you.
Perfect.
Thank you, Donia.
Introduction, Nicola. I'm also very glad to be here. And actually, our common friend is here, Aliena. So thank you.
Oh, yeah. Nice.
Yeah.
Okay.
Okay, so let me share my screen. Okay. Let me know if it's okay.
Yeah, we can see your screen. It's okay.
Perfect. So hi, everyone. Think about your favorite programming language. Mine is Go. As Nicola said, I'm a Golang backend developer. And imagine this favorite language, and you can run your program with this language running on embedded places, like small places. With Go, this is possible thanks to TinyGo. So today, I will explain to you what is TinyGo and go through some examples together. So Hone, let's shrunk the Gophers together. So my name is Donia Chaiehloudj. I'm a Golang backend developer at Powder, and we are building a social app for gamers. As Nicola said, I'm a Google developer group organizer in my area in the south of France. And I'm also striving for diversity and women in tech. So I'm engaged and involved in a local organization called WAT06, and we run events to elevate women like the Women Techmakers. You can find me on social medias. I would be more than happy to connect with you. So please add me. And so let's begin. What is Go? First, Go is a programming language for the one that didn't know, and it makes it easy to build simple, readable, and efficient software. So what is TinyGo compared to Go? Or what is not TinyGo? TinyGo is not a language. TinyGo is a compiler for the Go programming language, but it's for smaller kinds of systems and like embedded systems. So what are these small places that I'm talking about? It can be microcontrollers, or it can be WebAssembly, like for browsers, servers, for example. But today, I will focus on microcontrollers. So this is a small place with a small memory, actually. So let's see when we compile a program written in Go with its own compiler, Go, and with the TinyGo compiler. I will go through this example. This is a basic hello world, but for the ones that are not familiar with it, I will explain the code. So first we have the package main, because this is the main application. Then we have the import, the format, because we want to print and display text. And in the main function, what we want to do is to print the hello world sentence. So this is the most common example that we see in programming language. And I don't know if you're a programmer, but if you are, please, I saw there are emojis and you can react. So please react with a thumb up. And just I wanted to show you the difference between the size of the file when you compile it with Go and TinyGo. So with Go, this is the Gopher here. the size is 1.7 megabyte, and compiled with TinyGo, the Gopher in the microcontroller here, it's 1.2 megabyte. So you can see that there is a huge difference actually between the two files. So let's see how it works, because it's not about cheating. It's all about compilation theory. I will go through it briefly. So this is the TinyGo compilation pipeline schema, very simplified. We have the source code that is written in Go. Then we use the Go compilation toolchain. So Go has its own compiler because it's a cool language. And we are using these standard libraries to compile the code. Then we have TinyGo, the layer that does the optimization at the compile time. And then we are using LLVM, which is just a framework, a toolchain technology to build compiler, like to create compiler. It's used, for example, in C with thanks to Clang. And at the end, what we want, this is an executable binary that we can run actually somewhere. So now that we saw theory, let's play. So today, all the examples that I will go through are based on an Arduino Nano 33. The first example is called Hello World for hardware. So we will make a light blink. The code that will actually does the light blink is here. So I will go through again quickly. We have the package main. Again, this is the main application that we want to run. We import the package machine because machine is standard library from TinyGo that makes it easier to communicate with hardware. Then we have time because we want to manipulate time. And in the main function, I will create the LED that will make the light. I will configure it as a pin output because I want to see something from it. And forever, I will set the LED to low, which means I will turn the light off and wait for 500 milliseconds. Then I will set the LED to high, which means I will turn the light on and I will wait for 500 milliseconds. So this is the program that makes actually the LED blink. How we put this code on the microcontroller? We will use a command from TinyGo called flash. So TinyGo command flash, and we specify the target, which is our board, here the Arduino Nano 33, and the name of the program. Here I just put hello.go. TinyGo flash compile the code, write it on the microcontroller, and runs the code. So the expected output after this command, it's something like this, a LED blinking. But let me show you what it looks like in real life. So here I'm launching a make LED. It's just doing the TinyGo flash that we saw, specifying my target, Arduino Nano 33, and my program here is called blink.go. So here it's gonna write on the microcontroller the code. Oh, sorry, the demo. Okay, let me unplug and plug. It's gonna be fine. Let me reset the Arduino, delete this, and wait and try again. Hopefully it's gonna work. Yay, okay. It's actually, so you can see that we have verified successful. It's done. And I'm gonna show you what it looks like on my Arduino. I guess you can see my LED blinking right now. Can you see my camera and my slides at the same time? Yes, thanks, Nicola.
Yeah.
Perfect. Okay. So it was the simple example. So let's see another example that is a little bit more complicated. It's called serial port. And basically what we're going to do is print a text from the microcontroller to our computer. So we have a code that is running on our microcontroller, printing the text, and it will actually we will plug it to our computer, and it will send data 1 bit at a time, because this is a serial port, to the computer. And on the computer, I will launch a program called readserial.go that will read line by line the output from the serial port. I will not display it today, but you can find it at the end. I have a link to my repository, so you can find all the samples. So the serial port, just to mention, you can find it on /dev if you're running on Linux or OS X. And this is the name of it, the USB modem, because it's plugged on USB, and the number. And at the end, we have what we want, a human readable output. So we can see actually the text that is displayed, not in 0 and 1. So here is the code to write on the serial port. Again, we have the package main application. We use the import FMT, which is the format to print. Then we use time to actually manipulate time. And in the main, forever, I will actually retrieve the time.now, and I will print it. So I will have the hour, the minute, and the second. And I will say hello to the women Techmakers. Then we have the time.sleep. So we wait for a second, and there is no value here, no number, because this is the default value in Go. 1. So in peak here, you can see this is the main part that we want to see. So the expected output will be there. We run the program go run. So we build and run the code called readserial.go that will read line by line the output from the serial port. And we can see that every second here, we can say hello to the women Techmakers. So let's try live how it will look like. Make hello. Hopefully it's gonna work. So again, we have the TinyGo flash command. We specify the target, the Arduino Nano 33, and here my program is called serial.go. We can see that it's verified successfully, and let's see the pour. So we can see here the time. Actually, on a microcontroller, the clock is beginning to 0, and because each time we launch a new program, we reset the clock of the microcontroller. So we can see actually that every second here, we have hello to the women Techmakers. Okay, so we saw some examples of pretty simple with only the board. Now, the next example is called It's Getting Hot, and it's all about temperature. We want to retrieve temperature and humidity from a sensor and print it actually on the computer as we saw the hello women Techmakers. This is the schema of the circuit. So here we have the Arduino Nano that I just showed you. And here this is the sensor, the DHT22 it's called, and it's taking the humidity and the temperature. So basically in black here, you can see that pin ground is plugged to pin ground on the Arduino. In red, we have the voltage here plugged to the voltage, 3 volts. And this pin is the data, and it's plugged to D6 on the Arduino, which is important, the D6. So in real life, it looks like this. It's less sexy, but it does the job. So let's go through the code. We have the package main. Again, the main application. In the imports, I have FMT to print. I have machine to abstract the layer with the devices. I have the time, and the new one here is tinygo.org, and we have drivers. So this is a library from TinyGo that, again, enables to abstract the layers, the communication between the microcontrollers and the setup. So we just abstract the 1 and the 0 and the byte manipulation. It makes life easy and more readable, basically. So in the main, this time we configure the data pin this X, I told you it was important. The DHT sensor here, we create a new one with the pin that we defined, and we precise the DHT22. So it specifies the type of the sensor, because there is also the DHT11, for example, and we do not retrieve the data the same way. Then forever, we will call the method that is asking for the measurement. So we send a signal to the sensor saying, retrieve me temperature and humidity, and an error in case something went wrong. We just handle the error case and we print the error. And then in the case of everything went well, we print again the current time.now, using the hour, the minute, and the second, and the temperature in degrees Celsius. Here it is divided by 10 because the microcontroller sent it times 10. Same for the humidity in percentage. It's divided by 10 here. So now we are happy that we printed it, and we will wait for 2 seconds. 2 seconds here is pretty important because the sensor is slow to take the data and to take the measurements. So we don't want to actually ask for data while it is sending. So just waiting to finish to send the data and ask for a new one. Again, here we have the main important part, and the expected output should look like this. So again, we run the program called readserial.co to read line by line the program. Then we have every 2 seconds here, the temperature in degrees Celsius and the humidity. Okay, so let's do the demo. Make here. So the command here is TinyGo flash again. We send the program to the microcontroller. Then we specify our Arduino Nano. And here we have the program is called thermometer.go. And it's successful. So let's read from the serial port. Again, it begins at 0. We restarted the microcontroller. And we can see that every 2 seconds here, we have the temperature and the humidity. So let me blow on the sensor. And see what happened. So you can see that it's getting hot, isn't it? We have 31 degrees here, and the humidity is getting hot, but it takes more time. So the temperature and the humidity are not retrieved exactly, are not going up and increasing at the same time. So we can see here that the temperature is getting, the temperature is getting down and the humidity is getting up still. So you saw all these examples, but it's actually just a tiny bit of what you can do with TinyGo and with Go and the IoT world. This is an endless world of creativity. And here is an example of a tutorial from Aurélie Vache. She created a Game Boy Advance game in Go using Gophers here. We can see them, which is really funny. So I invite you to test it if you have an old Game Boy Advance. And the second example that I wanted to show you is from Olivier Fauchon. This is a composter monitoring app, which is very funny. With a few materials, he built it, and he built dashboard also, and everything is open source also. So you can see that we can do a lot of things, and just, you know, we can. Okay, so finally, we saw that TinyGo is a compiler for Go and for small places. We saw that the main command TinyGo flash can actually send the code on the microcontroller, precising the target and the name of the program. We know how to write on serial ports and read from it. And I wanted to mention that bugs in open source world can lead to opportunity, because when I was developing this program, I found a bug actually on the driver from the DHT, and it was really funny. I actually solved it and proposed a pull request on the TinyGo project, and it made me discover also the community behind it. Just, you know, open source world is full of bugs, but full of opportunities to meet new people and to write code. Don't forget to be creative. The theme is about progress, and it's by being creative that today I'm here and just discovering, you know, a new language. And don't forget to learn by having fun. There is so many playful ways today to learn. You can find all the sources of the code here. This is my repository that is called TinyGo Discovery on my GitHub, Donia Chaiehloudj. You can actually make contributions if you want and if you find bugs. And I wanted to finish on this quote from Eleanor Roosevelt: "Life was meant to be lived, and curiosity must be kept alive." Thank you. And again, if you want to find me on social media, I would be more than happy to connect with you.
Thank you so much, Donia.
Thank you.
That was a nice presentation. Do we have questions for Donia? And you can also connect with her. I sent her LinkedIn page. I dropped it in the chat. You could connect with her. Donia, could you also drop that GitHub link in the chat as